This lecture develops the theory of long-run exchange rates more formally by looking at the monetary model of long-run exchange rate determination. From our last lecture, we had an expression for PPP that gives us the nominal exchange rate as determined by the ratio of the price levels for the two countries in question. We however noted that because PPP does not hold in the short run, this expression does not provide a theory for the current nominal exchange rate, but rather for the future or long-run nominal exchange rate. So even though in what follows we shall be speaking about the exchange rate, you should keep in mind that this is the exchange rate that is expected to hold in the future. This expression, though, because it's a long-run condition, brings up further investigations. We know that in the long run prices are fully flexible and are endogenously determined. We therefore have to extend the PPP expression to include a further set of determinants for the price levels in the two countries. To do this, we review our prior macro coverage on money markets. We first introduce a very basic model of money market equilibrium, which has the money supply being exogenously determined by the monetary authority in that country at some level, say MS, and money demand being determined fundamentally by the transactions demand for money, making it a constant function of national income. So MD, money demand, is equal to L bar PY, where L bar is a constant liquidity preference capturing the proportionality of money demand to national income, PY. Note that PY, which is national income, is the product of the price level and the real national income, or real GDP. The product PY is simply nominal national income or nominal GDP. In equilibrium, money demand equals money supply. Similarly, dividing both sides by P gives us the real money supply M over P as equal to the real money demand L bar Y. Remember, real variables reflect quantity, not monetary measures. The equilibrium condition M over P equals L bar Y is in the form of the quantity theory of money that says here that in the long run, with real incomes being constant, any changes in the money supply will be matched by an equal proportionate change in prices. Thus, rearranging the expression to make the price level the subject of the formula, we have that in the money market, in the long run, the price level is a function of the ratio of money supply to real money demand. Thus, in any country, the price level will increase in the long run when the country's money supply increases, or when that country's real incomes fall. Similarly, the price level will fall in the long run when that country's money supply is reduced, or when its real incomes increase. So we now have a model of exchange rate determination. Remember, that is a model of future exchange rate determination expressed by PPP, and where the price levels are functions of money supply and real incomes in the two countries. This is still a basic monetary model, but it does a lot. It tells us that the future or long-run exchange rate can be determined once we know what happens to the money supply levels or to real incomes in either of the two countries in question. These are all exogenously driven in our model, that is, money supply is determined by the monetary authorities in each country, given their discretion and stated policy objectives, and real incomes in the long run are a function of the country's productive capabilities, that is, its resource endowments and existing levels of technology. To illustrate, suppose the Bank of Japan decides to double its money supply in order to fight continued deflation in its economy. We assume that there is no policy reaction in the US over this period, and real incomes remain fixed in both countries. Then we will expect that this action will cause the future dollar-yen exchange rate to fall. This is because the action taken by the Bank of Japan will cause its long-run price level to also double, and this will cause the dollar-yen exchange rate to fall via PPP as expressed. So the long-run response to the action taken by the Bank of Japan is to cause the yen to weaken against the dollar. Often the exogenous changes in the model occur via rate changes. For instance, in the long run, economic growth happens and real incomes change. Similarly, monetary authorities may not change the levels of money supply, but rather their growth trajectories, say from 1% to 3%, for example. We can convert our basic monetary model to a dynamic form by taking the percent change in the formula. This now gives us an extended relative PPP expression where the rate of depreciation in the exchange rate is equal to the inflation rate differential in the two countries. This is in turn equal to the differential in money supply growth rates in the two countries minus the differential in the real income growth rates in the two countries. The second equality follows from the quantity theory, where inflation rates in each country are simply found by asking how much faster money supply growth is growing compared to the growth of an economy's real income. Intuitively then, inflation is the result of printing too much money, where too much is determined by how fast output is growing. Let us illustrate this. Suppose that US money supply is growing at 2% each year, and real incomes in the US growing at 1%. Suppose also that inflation in Japan is at negative 2%, that is, they're experiencing deflation of 2%. If the Bank of Japan increases their money supply growth rate by 2%, what will happen to the exchange rate? Remember first that this is the future or long-run exchange rate we are speaking about. The basic monetary model tells us that the rate of depreciation in the dollar-yen exchange rate is equal to the inflation differential in the two countries. The inflation rate in the US is found by the difference in the growth of money supply and the growth of real income. So that is 1%. The expected depreciation of the dollar-yen exchange rate is therefore computed as being equal to 3%. The dollar is therefore expected to depreciate by 3% against the yen before the intervention. After the intervention, however, Japanese inflation rate is expected to rise to 0%. As a result, the expected depreciation of the dollar-yen exchange rate is now 1% as computed. So the monetary policy enacted by the Bank of Japan reduces the long-run expected depreciation of the dollar-yen exchange rate by 2%. This basic monetary model, however, suffers from a few limitations owing to our expression for money demand. Money demand in practice is not necessarily a stable function of national income under all circumstances. When economies experience periods of high inflation, the stability assumption becomes implausible. Further, since money is also an asset, its price also has an influence on the level of its demand. The price of money is the interest rate that could be earned if it were not held for transaction purposes, but rather in an interest-bearing account. In other words, the liquidity preference demand for money is tempered by the interest rate. That is, inasmuch as we might want to hold money for transactions or speculative purposes, a higher interest rate will make rational individuals reduce their demand for money as the cost of holding money in liquid form becomes too high. Thus, a more realistic model of money demand has it as a decreasing function of the interest rate and as an increasing function of national income. Equilibrium in the money market is now revised slightly to show that real money supply is equal to real money demand, where the real money demand is now given by the liquidity preference based on interest rates and real incomes. Rearranging this, we now have, as before, a formula for determining the price level in the long run. The price level P is given by the ratio of money supply to the refined real money demand. The money market equilibrium is depicted in graph form on this slide, with the nominal interest rate on the vertical axis and real money balances on the horizontal axis. The real money supply MS over P is a vertical line placed at the level that the monetary authorities want it to be, given their choice of the money supply level. The real money demand function is an inverse function of the nominal interest rate, holding real incomes constant. In equilibrium, they are equal at some interest rate I star. Note, however, that this is the long run, and with prices fully flexible, it's the price level that adjusts to ensure this market is in equilibrium and not the long run interest rate. As we shall see very soon, the long run interest rate is driven by other things. So if money supply or real incomes change, the price level changes to restore equilibrium in the money market in the long run. The refinement of the demand for money and the equilibrium condition in the money market, as we alluded to already, means that the nominal interest rate in the long run needs to be understood in terms of how it is determined, since, unlike money supply and national income, its level is not exogenous per se. So let's proceed by first starting with relative PPP. The expression says the expected depreciation in the exchange rate is equal to the inflation differential across the two countries. We next introduce the UIP condition, using its approximation form, which equates the interest rate in one country to the interest rate in the other country plus the expected depreciation of the exchange rate. So rearranging the UIP condition gives us the expected depreciation of the exchange rate as equal to the interest rate differential in the two countries. Substituting the interest rate differential for the expected depreciation of the exchange rate in the relative PPP formula, we have that the interest rate differential is equal to the expected inflation rate differential in the two countries. By rearranging this, an expression for the interest rate can be obtained for both countries. And because it involved the use of relative PPP, this is an expression that's expected to hold in the long run. For the United States, the long run interest rate is therefore given as the sum of the expected inflation rate in the US plus the difference between the Japanese long run interest rate and their inflation rate. Since Japanese variables are exogenously determined by their own idiosyncratic policies, the formula tells us that US interest rates are ultimately determined by the expected inflation in the United States. By an analogous reasoning, Japanese interest rates are ultimately determined by the expected inflation rates in Japan. While we are still at it, the foregoing actually leads us to a very important outcome. First, Let's consider that combining UIP and relative PPP, we had that the interest rate differential in the two countries is equal to the expected inflation differential in the two countries. We can rearrange this expression to bring the respective country variables over to the same side of the equality sign, and we observe that the difference between a country's interest rate and its inflation rate is equal for both countries. But what is that difference? It is the real interest rate. Thus, when PPP and UIP hold, the real interest rates are equal across countries. Note, this is the real interest rate, not the nominal interest rate. This outcome was lurking behind our initial expression for the long-term interest rate in each country. And we can see that by simply replacing the difference between Japan's interest rate and their inflation rate by the common real interest rate. We now have that the long-run interest rate in the United States is equal to the US inflation rate plus an exogenously determined world real interest rate. Similarly, the long-run interest rate in Japan is equal to Japanese inflation rate plus an exogenously determined world real interest rate. The real interest rate is exogenous because it is determined by overall global saving and investment decisions. Thus, this expression for the long-run interest rate is known as the Fisher equation, and the resulting empirical proposition that it suggests is known as the Fisher effect. The Fisher effect says that in the long run, the nominal interest rate will adjust one for one with changes in the expected inflation rate, leaving the real interest rate unchanged. The Fisher effect is actually borne out in practice as empirical studies show. Let us now walk through a brief illustration of these results. Suppose Canadian interest rates are at 2%, and the long-run inflation rate is expected to be 1% in Canada but 2% in the United States. What would be the long-run interest rate in the United States as a result? Next, what would happen to US interest rates if US expected inflation increases by 0.5%? To answer these questions, first recall that for any country, the real interest rate is given by the difference in that country's nominal interest rate and its inflation rate. So in Canada, the long-run real interest rate is 1%. Since this is the common long-run real interest rate for all countries, as it is the globally converged two real interest rate in the long run, then this means that US interest rates will be 3% as computed. Now, if expected inflation rises in the US by 0.5%, then by the Fisher effect, the long-run nominal interest rate in the US will rise by 0.5%. So it will no longer be at 3%, but now 3.5%. We now have a more general monetary model for determining exchange rates in the long run. That is, a model for determining the future or expected exchange rate. This expression has the nominal exchange rate equal to the ratio of the price levels across the two countries, which in turn is equal to the ratio of the relative money supply to real money demand levels across the two countries. This can alternatively be expressed as the ratio of money supply in the two countries divided by the ratio of real money demand in the two countries. Further, since the real money demand is a function of an endogenously determined long-run interest rate, this rate is in turn a function of the inflation rate, and the inflation rate is further determined by the difference between money supply growth and real income growth in the long run. In dynamic form, Assuming that interest rates are constant, then we have an expression for the general model that's identical to that we had for the basic model, where the expected depreciation of the exchange rate is equal to the inflation differential between the two countries, which is in turn equal to the difference between the money supply growth rates in the two countries minus the difference between the real income growth rates in the two countries. Let's consider now an illustration that utilizes the general model as follows. Suppose that the Bank of Japan decides to fight deflation and it doubles its money supply. Assuming that no other changes happen to real incomes in Japan or the United States and there is no monetary policy action taken in the US, what is the effect of this policy on the exchange rate? The answer is the same as the basic model would have predicted, since the policy has nothing to do with real money demand. Japanese price levels rise in tandem to clear the money market, and this causes an appreciation of the dollar-yen exchange rate in the long run. We show this in graph form here. First, in the Japanese money market. Initially, it's in equilibrium at I star. Then the monetary authorities increase money supply from MS1 to MS2. However, the price level adjusts immediately as prices are fully flexible in the long run from P1 to P2 by the same proportion, so that real money supply stays the same. As a result, the long-run interest rate is unaffected in the money market. However, as we show next, the effect of the price level increase via PPP in the long run causes the dollar-yen exchange rate to fall as the yen weakens against the dollar. As another illustration, let's suppose the Federal Reserve decides to fight inflation in the United States, and it decreases the growth rate of money supply. Assume that no other policy response takes place in Japan and that interest rates are constant in both countries. How will this policy affect the exchange rate? Since this is a growth rate change, we look at the dynamic version of the general model. The decrease in US money supply growth rate will cause the inflation rate in the US to fall by the same rate. That fall in the US inflation rate, however, causes a fall in the US long-run interest rates because of the Fisher effect. This means that in the US money market, real money demand increases and real money demand exceeds the real money supply. The US price level therefore falls to increase real money supply in order to clear the market by restoring equilibrium. The fall in the US real money supply via PPP causes the dollar-yen exchange rate to fall and thus appreciate. The policy therefore leads to a long-run strengthening of the dollar against the yen. These results are depicted first in the US money market. We see that the policy, while not affecting the level of money supply since that's unchanged, because it was a growth rate change, not a level change, has however caused the interest rate to fall by the Fisher effect. Prices fall in the US in the long run in reaction to the increase in real money demand for the same level of money supply, so that real money supply shifts out and equilibrium is restored. The reduction, however, in the US price level causes the dollar-yen exchange rate to fall via PPP as depicted here. The long-run response of the Fed policy is therefore to strengthen the US dollar against the yen as the exchange rate appreciates. From the general monetary model, one striking observation to be made is the linkage in nominal variables in the long run. This ultimately follows from the observed long-run neutrality of money, where it's accepted in general that in the long run, monetary policy does not influence real variables, but rather simply affects other nominal variables. This, however, provides avenues for countries to pursue nominal policy objectives by staking a policy position known as nominal anchoring. The choice of such an anchor or set of similar anchors defines a monetary regime a country chooses as a more or less formal statement of its long-run goal of keeping prices stable or inflation in check. A nominal anchor works by choosing to impose a constraint on a particular nominal variable, which in turn serves to credibly pin down another or other nominal variables such as inflation to some stable, predictable level. The foregoing suggests that there are three of such nominal anchors when it comes to pinning down inflation in the long run: an exchange rate target, a money supply target, and an inflation target that includes an interest rate policy. The exchange rate target works based on relative PPP. So if we consider the United States and China, the expected depreciation of the dollar-yuan exchange rate will be equal to the inflation differential between the two countries. So if China, for instance, wished to credibly signal their willingness to keep inflation in the long run down to some fixed deviation from that of the United States inflation rate, they could do so by pegging their exchange rate so that this rate of depreciation is zero or some low constant magnitude. Assuming US inflation rates are low and stable, then inflation in China will reflect the same if the expected depreciation is zero or close to that. In other words, the Chinese policy would be to target the exchange rate to ensure that the yuan converts to the US dollar at some fixed rate that does not change over time. The money supply target comes from the dynamic expression of the quantity theory. It suggests that inflation rates in the long run will be given by the difference between the money supply growth rate and the growth rate of real income. The anchor variable here will be the growth of money supply. To achieve a given level of inflation, say 2% each year, then money supply will have to be set to grow at 5% each year if the economy's output or real income is growing at 3% each year. If the economy now grows faster at 5% each year, then money supply growth will be increased to 7% in order to maintain the same inflation goal. The inflation target with interest rate policy follows from the Fisher equation. Rearranging that equation gives the inflation rate as the difference between the nominal interest rate and the real interest rate. Recall, the latter is exogenous, so the target variable here is the nominal interest rate. The idea is to have a policy where the interest rate in the long run is determined, even though in the short run, monetary policy could cause it to deviate from that level. By credibly having such a policy in place, and for a given level of assumedly known real interest rates, the inflation rate can therefore be targeted at a long-run level. For example, if the real interest rate is 2% and the long-run inflation rate targeted at 2%, then the policy is to have the long-run interest rate always return to 4%, regardless of what's done to it in the short run through monetary policies. These are all appealing monetary regimes for countries to put in place to credibly keep prices stable at some level. However, the choice of which one to use will depend on the overall short and long-run objectives of policymakers, as some of these policies prevent other policy objectives from being carried out. An exchange rate nominal anchor is useful for a country with a past history of inflation, seeking to assure investors that prices will be stable going forward. In cases where output growth is fairly accurately predictable, a money supply target may be the regime to put in place. If, however, greater flexibility in the use of interest rates to stabilize the economy is desired, then the inflation target with an interest rate policy might be a preferred regime. In general, all three regimes cannot be in operation successfully at the same time within any particular country. We can now summarize this perhaps lengthy coverage. PPP linked with the money market in each country provides for us the monetary model of long-run or future exchange rate determination. Along the way, we have seen how inflationary expectations can influence exchange rates through the Fisher effect. We have also seen how the concepts and models we have developed can be used in setting credible long-run policy on inflation through the use of nominal anchoring. We are now ready to get back to our initial concern, which was developing a theory of exchange rate determination. We have one of the important building blocks required for this in the bag. That is, we have a theory for how future exchange rates are determined. So what is next? Well, first, let's take the quiz associated with this lecture, then start to read the next chapter on exchange rate determination in the short run, which is where our next interesting lecture will take us, as we look at the asset approach to determining the current exchange rate.